Hello guys, my name is Josiah Buxton and I'm a student in the EGR 333 class, and I'm going to be giving you a little introduction on PLCs and how they can be used. Right now I'm going to be demonstrating a lab that we've created in our EGR 333 class, and this lab was meant to simulate a Skynet defense system that would activate if three different conditions are met. The three conditions are if 3 out of 4 board members presses a switch simulating that they voted to have this defense system activated, if 2 different keys out of 4 different slots are pressed and are turned, and the last condition is if the president has a box that's close to him, or briefcase, if he presses a switch within there. And so I'm going to show you the circuit that we've made on the breadboard and how it interfaces with the PLC.
As you can see here, this is our circuit that we created. These 4 different input switches pertain to each of the board men that need to press their switch 3 out of the 4 in order to get the first condition activated. So I'm going to go ahead and do that. And as you can see, this output LED lights up when that condition is met. Now, the second condition is the 2 specific keys. It needs to be this key right here, which is this switch, and this one right here. So these are the 2 keys, and when this condition is met, that output LED also lights up. Now the third one is the presidential switch, and that is right here, this pulse switch right here that we can press. And as you can see, as soon as that one turns on, this is going to light up a 4th LED, and this is going to send a signal to the PLC saying that all the conditions have been met, and that's the Skynet countdown. There's going to be a 60-second countdown that starts up on the PLC based on when this input is seen, and then it can be only canceled by pressing the presidential switch again by using this button right here. So this is the actual PLC rack that we used for the lab. This is the PLC, and its job is to just perform logic on all of the inputs and create corresponding output signals. Now, it's all powered from the wall right here. This wall initially goes into a switch, and this switch then goes into the step power unit that converts the AC signal to a DC signal, and this 24-volt DC signal is what actually powers most of these modules. As you can see, this PLC is a 24-volt module, and this analog I/O is actually a 24-volt module as well. So essentially what we do is we just power these different switches. They provide 24 volts to each of the ports on these switches, and you can then take these switches and power other devices. So this wire and this wire right here are the analog inputs that are coming directly from the breadboard, and right here you need to make sure that you ground these analog inputs so they have something to base their signals off of. And one other important thing is that when you are working with a PLC and you're trying to connect it to other devices, it's important to ground from the PLC rack to the breadboard or whatever other device that you're using.
Alright guys, this is an example of a flowchart. This is the program that actually runs on your PLC. Right now I do have it connected to the PLC, so I can show you a real-time simulation. But the way you need to think about these flowcharts is the PLC begins and starts on this power on block, and then follows the arrow to whichever block it needs to go to based on values that it's given from the PLC. So I'm going to go ahead and actually start this simulation. So up at the top, you need to click download and go once you have it correctly connected and configured. And so right now you see that it's pretty much stopped at these 2 blocks. The reason why they're both green is because it's cycling so quickly between them, and because it's just going back and forth, and this is waiting now for the output LED saying that all 3 conditions are met, and waiting for that signal. So I'm going to go ahead and start that signal. And as you can see, now it begins to count down. It's cycling through the 60-second countdown. If I waited the whole entire 60 seconds, it would go down to this block right here that says Skynet activated. But otherwise, I'm going to show you how the second input. See, it's moving this input right in here and checking to see if the value is above 500, which it's only at about 118 right now because it's turned off. But I'm going to go ahead and turn that one on. And there it goes. It's deactivated by this presidential switch. So there you have it. This is just a quick simulation. I hope that you guys learned a little bit about PLCs and how they work.